What's up guys, welcome to the series about design patterns and how to implement them on AWS using only serverless services. In this episode of Serverless Patterns, we'll look at an architecture that combines AWS services with Sharp, the open source image processing software, to build an optimized solution for dynamic image manipulation. This solution was first published in the AWS architecture blog, a great resource by the way for reference architectures, but I wanted to deconstruct it to simplify it and make it more approachable. But I'll link to the original article in the description anyway. As always, we'll look at the use case for this solution, its benefits and considerations, but this time, in addition to that, I'll also be providing a full CloudFormation template to implement the solution with one click. So make sure to keep watching for that. You want to implement the image handler solution if you're looking to introduce some sort of dynamic image handling in your application. Maybe the application you're building handles images uploaded by users, and in your meeting with the product owner, they mentioned the following requirements: maintain high quality images on websites and mobile applications, dynamically adapt image dimensions to screen ratio, detect and moderate inappropriate content like blood, violence, nudity. So that's when I want you to think about using this solution, which will have the following benefits. First, you'll be able to deliver dynamic images at runtime based on your customer's device. Second, the automatic content moderation through Amazon recognition to detect and blur inappropriate, unwanted, or offensive images to create a safer user experience and comply with local and global regulations. We'll also be using the facial recognition capabilities of Amazon Recognition to crop images when needed. And an added bonus, by eliminating multiple versions of the same image automatically, of course, this solution will allow you to save a few dollars on storage costs through its automated version control. And now onto the considerations. So many companies rely entirely on human moderators to review uploaded content, or they simply react to user complaints to take down offensive or inappropriate images. But it's obvious that human moderators alone cannot scale to meet these needs at sufficient quality or speed. By using Amazon Recognition for image and video moderations, human moderators can review a much smaller set of content, typically between 1 to 5% of the total volume already flagged by machine learning. In other terms, 1 to 5% of content might go undetected by machine learning algorithms. If your business has strict rules and cannot tolerate such a margin, I encourage you to have a look at Amazon Augmented AI, which is, by the way, already integrated with the Amazon Recognition and allows you to set up human workforce that review content that might have escaped the machine learning scope. And the way it works is actually pretty simple. You start by setting up a confidence level, say 70%. If Amazon Recognition is not 70% or more confident that the uploaded image has inappropriate content, it will automatically generate an email with all required information about the image, send it to the team you set up before. And every time such an interaction occurs, Amazon Recognition gets one bit smarter by learning your preferences. So in a way, you're also training the algorithm to work according to your own needs. And I'll make sure to include a link in the description for how to start with Amazon Augmented AI. And now onto the architecture. So how does this solution look like on AWS Cloud with a pure serverless stack? Say one of your users is asking for an image. This query then goes through a CloudFront distribution that provides a caching layer to reduce the cost of image processing and the latency of subsequent image delivery. In other words, once an image is generated and cropped for a specific device, it's cached on CloudFront, so we don't have to process it again should it be required anytime soon. This reduces latency and eliminates the cost of reprocessing the image. But if it's a fresh request, if the image is not cached, we need to do the processing to prepare it. And for that, we use an API gateway to provide endpoints to call the Lambda function that handles the computation. There are no servers to provision or to manage. This Lambda function retrieves the image from an existing S3 bucket and uses Sharp to return a modified version of the image to the API gateway. Pretty straightforward. And now you can add all sort of things like Lambda destinations to handle errors, But for now, let's create just another S3 bucket where we log the operations. This is simple and effective because you can then later use this bucket as an entry point for all kind of analytics you'd like. And by the way, when you use the provided CloudFormation template, you'll be asked whether to create this log S3 bucket. And if selected, the solution will deploy a simple web interface where you can interact directly with your image handler API endpoint using image files that already exist in your account. So this is just a cool way of trying the solution and playing with it. Another choice you'll be presented with is to activate an image URL signature feature. And if you choose yes, the Lambda function will be configured to retrieve the secret value from your existing AWS secret manager to validate the signature. And you probably want to enable it in order to have a secured end-to-end request and response, which allows you to prevent unauthorized use of your proprietary images. And lastly, if you choose to use the smart crop or content moderation features that we spoke about in the previous slide, the Lambda function calls Amazon recognition to analyze your image and to return the results. So to recap, when an HTTP request is received from a client, it is passed from CloudFront to API gateway and then forwarded to the Lambda function for processing. If the image is cached by CloudFront because of an earlier request, CloudFront will return the cached image instead of forwarding the request to the API gateway, which reduces latency and eliminates the cost of reprocessing the image. Requests that are not cached are passed to the API gateway, and the entire request is forwarded to the Lambda function. The Lambda function retrieves the original image from your Amazon S3 bucket and uses Sharp to return a modified version of the image to the API gateway. This solution also utilizes Stambor to apply dynamic filters on the fly. Additionally, the newly manipulated image is now cached at CloudFront for easy access and retrieval. The end-to-end request and response can be secured by using the solution's signed URL feature via AWS Secret Manager, which allows you to prevent unauthorized use of your proprietary images. And lastly, this image handler uses Amazon recognition for face detection in images submitted for smart cropping, allowing for easy cropping for specific content and image needs. And if you're looking for a step-by-step guide to use Amazon recognition, please check out this previous video where I configured it with my home security camera to detect and notify me when someone approaches my house. Lastly, I'll make sure to provide various links to the resources I mentioned in the video, including the CloudFormation template and a couple of articles to help you start with Amazon recognition and Amazon Augmented AI.
Turn it up now.